All right, 11.6 surface area of pyramid and cones. Got my little toys here. We're going to write down the formula. Okay, it's very similar to the other formulas that we did, the one about prisms. Okay, so let's go ahead and write the lateral area. And again, the lateral area is going to deal with, well, you're going to have one base, and this is a triangular pyramid. You're going to have one base, and then you're going to have, in this case, three sides that are triangles. Your sides will always, your side faces or your lateral area will always deal with triangles, and your base will change depending. So your lateral area is just going to be this: 1/2 perimeter, and then there's a cursive L, and I'll explain what the cursive L stands for. So the one we did yesterday for prisms was lateral area is just what? P times H. So this is 1/2. Okay, so that's the difference. It makes kind of sense that, you know, if it comes to a point as opposed to coming to a circle, it'd have less surface area. We're going to discuss what this is. So I'm going to mark this out because you don't need this because that's yesterday. P, capital P is for perimeter. This cursive L is slant height, okay, which is different than regular height. Okay, so regular height starts at the base, okay, starts at the middle of the base and extends all the way up to the tip. Slant height is on the side. So the height of this triangle is the slant height. So it doesn't start at the middle, it starts at the edge. So it is the side of it, not straight down the middle. That's the only difference. Okay, and you'll see it in your book or in your worksheet how it works. So that's lateral area, surface area. You should be able to figure out surface area. Surface area, how many bases do we have on a cone or a pyramid? I have one base, right? So it is the area of the base plus, okay. On a prism, it was what? 2 bases plus L, right? So it should make sense that this is just one base plus L because there's only one base on a cone or a triangle, okay? And a cone, of course, is a delicious shape that usually comes with ice cream, or in the olden days, it came with snow. But nowadays, snow cones aren't cones, are they? They're cups, right? They should call them snow cups. But in the olden days, they did snow cones. But it's basically all a trick to make it look big, but there's not that much in it, right? Is that what a cone is for? Well, once we get to volume, we'll discuss that. All right, that's basically it. We're going to do a sample problem, and then we will move on. So I'm going to draw a sample problem here. I'm going to call this is going to be 4 by 4. Okay, you don't see it. That's kind of a cone. So we're going to have a 4 by 4 base. I'm going to call the slant height. And we would just put it, usually would put it in a different color, and so I put a slant height, I'll call that 12. All right, so let's try to find the lateral area first. The lateral area, well, let's draw our shape. We've got a square base. It's 4 and 4. What's the perimeter of this base? 4 plus 4 plus 4 plus 4 is going to be 16. What's the area going to be? 4 times 4. Oh, that's easy. So let's put it in the formula. Lateral area, 1/2. Perimeter times the slant height. The slant height was 12. Okay, put that in your calculator. You should get an answer. Lateral area is, and we're running out of space, lateral area is if I can get this to work. 96 units squared, right? Surface area, 16 plus 96. 112 units squared. Okay, cone is going to be the same thing, but instead of perimeter, what are we going to use? Circumference. Only difference.